Class 12, 5th chapter, Continuity and Differentiability, Exercise 5.2. So we have found the derivatives of all the 8 functions and we have solved question 9 using 2 methods. Now let us solve for the 10th one. F of x is equals to greatest integer function. So they have given 2 points, that 2 cases, x equal to 1 and x equal to 2. So first let us solve for x equal to 1. The question is, prove that the greatest integer function defined by f of x is equal to greatest integer function of x, where x is greater than 0 less than 3 is not differentiable at x equal to 1. So this is the point they have given, not differentiable at the point x equal to 1. So already they have mentioned it is not differentiable. Then what we have to prove? For that we'll understand when the function will be differentiable at a point. So f of x is differentiable at a point x if left hand derivative is equal to right hand derivative. So if these 2 conditions will satisfy, then we say that f of x is differentiable at a point x. So here limit h tends to 0, f of c, so the value of x is c. So f of c is minus f of c minus h by h is equal to limit h tends to 0, f of c plus h minus f of c by h. So here we will prove for left hand derivative and here right hand derivative. So before that, let us first analyze what is the greatest integer function, which we studied in class 11. So what are integers? We have 0, positive 1, positive 2, positive 3, minus 1, minus 2, minus 3, so on, right? So we call this package or the collection of these numbers as integers, right? No fractions, no decimals, right? So how does the greatest integer function works? So if you supply integer to this function, like these numbers, if you supply integer to this function as an input, then the output from this function, it will happily give you the same integer, right? But if you give any other value, any other real number except integer, so except these numbers, if you give fractions, decimals or any other number, so this will give back a lesser integer value. Lesser integer value than the input. So let us see what is the meaning of this using a number line. In the question they have given the values of x, the domain of x from 0 to 3. So we will use this in the number line 0, 3. So this is an open interval because we will not take 0 and 3. So here you will get 1 and 2. Now we have 2 integers here, 1 and 2. Even 0 and 3 are also integer. So if you give integer, we understood that the value will be 1, right? Output will be 1. So if you give 2 to the function, the output will be 2. Now let us take a number which is lesser than 1. Lesser than 1, right? This side, left side. Let us say 0.5. Now it will select either 0 or 1, but it will select the number which is lesser than itself, that is lesser than 0.5. That is 0, right? So it will select 0. The output will be 0. So if you send 0.5, the output you will get is 0. Now if you send 0.8, somewhere 0.8 here, which is lesser than 1. So out of 0 and 1, it will select the lesser integer and the output will be 0. Now let us give a number that is greater than 1, 1.2. So if you give 1.2, which is greater than 1, then out of 1 and 2, which is the least integer here, 1. So the output will be 1. Will be 1. Now 1.5, which is greater than 1, 1.5, which is greater than 1. So out of 1 and 2, which integer it will select? The least integer. So 1. So from this we can say that a number lesser than 1, the output will be 0, and the numbers greater than 1, the output will be 1. So number lesser than 1, can we say it as 1 minus h? 1 minus h, lesser than 1, right? And this side, all the numbers that are greater than 1, can we represent it as 1 plus h? So if you give the input as 1 minus h, all the numbers here, then the output will be 0. And if you give the number that are greater than 1, 1 plus h, the output will be 1. Right? Similarly, now let us check for 2. This will help to solve case 2. So if you give integer 2, you will get back 2. Now we will give lesser than 2. It is 1.8. So if you give 1.8, so 1.8 is between two integer 1 and 2. So this function will select the lesser integer. So it will give the output 1. It is, say that you have taken 1.95. So the two integers 1 and 2, it will select 1 because 1 is a less integer compared to 2. Okay, so if you give any integer that is lesser than 2, the output will be 1. Now let us give the integer that are greater than 2. Let us say 2.2. So between 2 and 3, 2.2, if you give the input, it will select the integer 2 because it will go for the lesser one. Now if you take the input 2.5, then the output will be 2. So because 2 is the lesser integer compared to 3. So what we can analyze here, suppose if you select the number 2, all the numbers that is lesser than 2, can we represent it as 2 minus h? And all the numbers that are greater than 2 as 2 plus h. So if you give the input 2 minus h, the output will be 1. And if you give the number 2 plus h, that is greater than 2, the output will be 2. Okay, so we are going to use this in both the cases. Now let us solve for left hand derivative. Limit h tends to 0. So in the place of x, the first case is x equal to 1. You can also write c. That's okay. So at x equal to 1, so f of 1 minus f of 1 minus h divided by h. Now what we have to substitute for f of 1 and f of 1 minus h in the next step? For that, we will go to the function. F of x is equals to greatest integer function of x. So if you give input 1, so what is the output you will get? This is an integer, so you will get the output as 1, right? Now f of 1 minus h, that is 1 minus h, just now we, so if it is 1 minus h lesser than 1, right, lesser than 1, 1 minus h is lesser than 1, so the output will be 0. So we'll substitute here. So this implies limit h tends to 0. So either you can directly write it, but this step is very important, so let us write this step. So f of 1 will be, we'll write this both step, okay? Then f of 1 minus h divided by h. Now this implies limit h tends to 0. The value of this is 1. and the value of this is 0 divided by h. This implies limit h tends to 0, 1 minus 0 is 1 by h. So as h approaches 0, the function will be not defined, or we can say undefined. So we will write not defined. That means limit does not exist at this point, right? Because this will be equal to, we can write infinity here. This is not defined. So when h approaches 0, the value of the limit, it's not value of the limit, it approaches, or it will increase to infinity. So we will write not defined. Now let us check for right hand limit. Limit h tends to 0, f of x plus h. So in the place of x we will write 1 plus h minus f of 1 divided by h. So this implies limit h tends to 0. So f of x, so how do we going to represent it? 1 plus h minus 1 divided by h. So this step is very important. You should not skip this. Now this implies, so what you have to write in the place of 1 plus h? 1 plus h. So here 1 plus h will be equal to, that is numbers that are greater than 1. So we'll get the lesser value, because since 1 plus h is greater than 1, it will go for the less integer 1. So here you will get 1 minus, if you give integer, you will get back the same integer, divide by h. Now limit h tends to 0, 0 by h, right? This will be 0. If numerator is 0, the output, the final result will also be 0. So here the limit value is not defined, and here the limit is 0. So they are not same, they are not equal. So what we can conclude? That left hand derivative is not equal to right hand derivative. So since left hand derivative is not equal to right hand derivative, what we can conclude? Therefore f of x is equal to greatest integer function of x, where x is greater than 0 and less than 3, is not differentiable, at x equal to 1. Hence proved. Now let us solve for the case 2, where x value is equal to 2. So in the left hand derivative, this implies limit h tends to 0. So at x equal to 2, we will write f of 2 minus f of 2 minus h divided by h. Now this implies limit h tends to 0. So how you will write f of 2? So we know f of x is equals to greatest integer of x. So f of 2 will be greatest integer function of 2, a value of 2, minus, so similarly this we will write it as 2 minus h. So this is the important step, divided by h, right? Now this implies limit h tends to 0. If you give input 2, the output will also be 2. If you give 2 minus h, this 2 minus h, it will be between 1 and 2. So the lesser value is 1. So we will write output as 1, because 2 minus h is lesser than 2. So here we will get 1 divided by h. Now this implies limit h tends to 0, this is 1 by h. So we know that if the denominator is 0, it is not defined. So we will write infinity, and it is not defined. Okay. Now right hand derivative, this implies limit h tends to 0. So in the place of x we will write 2 plus h minus f of 2 divided by h. So this implies limit h tends to 0. So how we are going to write here? By using the function, if f of x is equals to greatest integer of x, but in the place of x we have 2 plus h, so here also we will write 2 plus h. So we will get 2 plus h, and here we will write 2 divided by h. Now this implies limit h tends to 0. So 2 plus h, what is the value output you will get if you give input as any value which is 2 plus h? It will be 2, because 2 plus h is greater than 2. So between 2 and 3 it will select the lesser value, which is 2. So here you will get 2 minus, and if you substitute 2 the integer, you will get back the integer 2 divided by h. This implies limit h tends to 0. 2 minus 2 is 0, 0 by h. So if numerator is 0, you will get the final limit value as 0. So here left hand derivative is not equal to right hand derivative. Hence we can say that the function is not differentiable at a point x equal to 2, because they are not equal. Left hand derivative is not equal to right hand derivative, and left hand derivative does not exist at all. So we completed both the cases. You can check in the playlist for other videos.